right, so for problem number 1, we want to know which one of these fractions is going to wind up actually being a positive fraction. Lil? C, right? If we see each one of these, A has how many negative signs? 1. It just has 1 negative sign. What about B? How many negative signs? 1. What about C? 2. So if we see that we've got 2 negative signs, a negative over a negative is just a positive, right? And then D only has 1 negative sign. So whenever we see any fraction that actually has 2 negative signs written in it, then we know that this is actually going to be a positive. That double negative becomes a positive. All right, for problem number 2. Problem number 2, we said, hey, x is going to be at the value negative 1/2. So right above x, I'm going to go ahead and put down that this is negative half. And what I want to know is if I were to add these different values to x, which points would it take me to? So in my calculator, I should just go ahead and do a whole bunch of addition problems, right? I should do negative half plus 0. If I do negative half plus 0, what is that going to equal? Negative half, right? If I add 0, I don't move anywhere, so that's going to keep me at point x. So no change happened there. Okay, what if I take negative half, and this time I'm going to add, here, we'll do pink, because it's a negative. We're going to add a negative 3/4. So if I do a negative half and I add a negative 3/4, what is that going to give me? Negative 5/4, right? Negative 5/4. So is that going to take me, so there's only 2 negatives, right? There's an A and a B. Which one of those do you think negative 5/4 would be? A, right? It's further away from 0. C is at where 0 is. So I'm actually getting further away from 0 by adding a negative to it. So adding that negative 3/4 is going to take me to point A. So I'm actually going backwards. Okay, when I add a negative 3/4 to it, I'm working my way backwards. Okay, what about when I add 1? When I add 1 whole, so I'm going to go ahead and I'm going to circle that in my green, and I'm going to add 1 whole. What is that going to equal? If I do negative half and I add 1 whole, that's just going to equal a half, right? A positive half. A positive half. So is that going to take me to B, C, or D? If it's a positive half, am I going to B, C, or D? D, right? I'm going to a positive, which means I have to be to the right of 0, and C is at 0. So I'm going to have to be even further past it. So this is actually taking me all the way to D when I add 1 whole, okay? So if we're going to go to D, I'm going to put plus 1 right next to D. Okay. All right, next one, I want to add a half to it. So I'm going to take negative half, and I'm going to add a half. Negative half plus a positive half. What's that going to equal? Jordan? 0. That's just going to equal 0. So which one of those points is 0? C, right? If I take negative half and I add a positive half, that's just going to equal 0. So I'm going right to C. Okay, and then the last one that we have left here, we've got adding 1/3. So if I were to take a negative half and I were to add 1/3, that's going to come out to 1/6, negative 1/6. Okay, it's still negative, but it's a lot closer to 0, isn't it? It becomes a much, closer to 0 negative than what we started with. So we're going to actually go to point B. So all you're doing is just taking the values that they're giving to you here and adding them on to a value you know to see roughly on a number line where would it place you. Are you still going to be in the negatives? Are you going to move to the positives? Are you going to be a negative that's further away from 0 or a negative that now becomes closer to 0? Are you going to go to 0? Okay, so these are all the different ways that it can change. Does it not change at all? All right, let's take a look at our word problems here. What? Those are the answers. So it's not multiple choice. It's saying, hey, which one of those values did you add to get to point A? Well, we added negative 3/4 to x to get to point A. So these are the answers. These are the values you add to x to get to those points. Okay? It wasn't a multiple choice, Ethan. It wasn't a multiple choice question. It was a multi-part question. So what did we add to A in order to go from x to A? Or what did we add to x to get to A? We added a negative number to move us backwards. All right? Okay, problem 3. Nick is celebrating his birthday and he wants to bring in cupcakes for the class. There are 24 students in the class. If 3/4 of the class want to have vanilla cupcakes, how many vanilla cupcakes should Nick bring in? Okay, so 3/4 is not a number of students, okay? It's just a portion. It's not a physical number, right? You can't be 3/4 of a student. So we're finding the portion of the class. What operation do we do when we see that we're finding a fraction of something? Who remembers? If it's a fraction and then keyword of something. Amara? Not subtraction, not division, multiplication. Okay, we're multiplying. So we know how big the class is. We know how many students are in the class. We want to find 3/4 of that value. So we're going to multiply. We're taking 24 and we're going to multiply by 3/4, and that's going to equal 18 vanilla. We want 18 vanilla cupcakes. And here's the thing, guys. It should make sense, right? If I want to bring in cupcakes to the students and I need to figure out how many cupcakes to bring in, if I test out these operations and I go, okay, well, maybe I'm going to add. If I add, I'm going to get a fraction. Can I have a fraction of a cupcake? No, I'm not going to make a fraction of a cupcake. Same thing with subtracting. If I subtract, I'm going to get a fraction. I'm not going to have a fraction of a cupcake. So the only other two operations are to multiply or divide. Now, does this say the whole class wants vanilla? No. So when I work it out, should the number be bigger or smaller than the whole class? Smaller, right? We only need 3/4. If I were to have divided and did 24 divided by 3/4, I would have gotten 32 cupcakes. 32 cupcakes is way more than how many kids are in the class. So you can use that deductive reasoning and going, okay, well, I can't add and I can't subtract. Dividing didn't work out because it gives me way more than what I would need. So multiplication is the last thing. Okay? All right. Problem 4. A pack of flour has 10 cups in it. A serving size is 2/3 of a cup. We want to know how many servings. Now this is one that we actually didn't go over, and I love this problem because it has a good key word that we don't tend to think of, but this key word right here, if I say how many servings, I'm actually going to go ahead and divide. When you're trying to figure out how many servings, those are portion sizes. How many portions can you create? How many equal sized portions can you create? So we're going to divide in this problem. Christian, what did you get? 15, right? If we take 10 cups and we're going to divide it into equal 2/3 portions, that's going to give us 15. So we get 15 servings. All right, last one. Megan has a block of wood that's 18.5 inches long. She's trimming off a piece of wood that's 4 3/5 inches long. How much wood is still there? What operation is that going to be? If we're trying to figure out how much is still remaining. Subtraction, right? See, if we say here, the word trimming it off. When we see trimming or cutting or removing, we're going to subtract. So we're going to take 18 and a half, and we're going to subtract 4 3/5. And that's going to equal 13 9/10 inches. So that's the remaining amount. Now, these problems were all single step problems, meaning you only had one operation that you had to do. You're either just going to add, or you're just going to subtract, just multiply, just divide. Today, we're going to look at some problems that involve multiple operations to solve. Okay, so you have to look through and you have to figure out what operations do I need to do, and in what order do I need to do them. Okay, so let's go ahead and flip it on over to the next page. And you're not going to have homework tonight. We'll have an assignment that you'll have all class period tomorrow to work on involving those multi-steps. All right, let's take a look here. So we've got a coffee shop, and at 7 a.m., the coffee shop served 24 people. So that's the number of people that we've had go through the coffee shop and they've ordered some coffee. Now we've got a fraction though. Is a fraction going to represent a person? No. Again, fractions are representing a portion of your whole. That 24 right there is the whole amount of people that came to our shop. 2/3 of those people that came had a regular cup of coffee. 1/8 of those people who came had a decaf coffee, and then the remaining people got a specialty coffee. Right off the bat, I see the word remaining. What operation do I think of when I see remaining? Jada? Subtraction. So I know right here that this is going to cause me to do some kind of subtraction. But I'm not going to subtract 2/3 and 1/8 because those aren't people. I need to change that into people first. But now, if I say it's 2/3 of these people that had regular coffee, what did we say a fraction of meant? What operation was fraction of? CJ? Multiplication. So for here, we're going to take 2/3 that had regular coffee. 2/3 of this 24. 2/3 of that 24. So we're going to do some multiplication for here. We're also going to do some multiplication with the 1/8. So we have 2 steps of multiplication and then 1 step that's going to have a subtract. So let's do our multiplication first. We're going to first multiply 24 times 2/3, and that's going to equal 16. Now that is a number of people. That is going to represent a number of people. And that number of people are who had regular coffee. And we're going to do the same thing again now for decaf coffee, but instead of multiplying by 2/3, we're going to multiply by what? 1/8. Good. So we're going to take 24 now and we're going to multiply it by 1/8. And that's going to come out to 3 people. So 3 people had the decaf coffee. So now I know a number of people who had regular, and I know a number of people who had decaf. So what are we going to do? We're now going to subtract. So we're going to take the total number of people, that was that 24, and we're going to subtract away our regular coffee drinkers, and we're going to subtract away our decaf coffee drinkers, and what's remaining is 5 specialty coffees. Okay, so again, it's multi-step, right? We had some multiplication and then we had some subtraction. So it's not just important to know your steps, like what operation you're using, but you have to know the order that you're going to do it in first. Okay, let's take a look at problem number 2. So now, Henry purchases coffee creamers in the bulk section at the grocery store. Its price is $2.60 per liter, and he's going to purchase 4.5 liters. Okay, so when you purchase items and you go up to the cash register, you give them money, right? Sometimes we give them cash, And what happened? Why did he receive money back? What does that tell us when it says he's going to receive some change back? What does that tell us? That they subtracted what? It's not quite subtraction. So just ignore the rest of this conversation. I'm telling you, you're going to go, you're going to give them money, and they're going to give you some money back. What does that tell you about the money you gave? William? Well, not talking about operations. I'm saying if I get change back, what does that mean happened? Okay. He says, hey, let's say that you gave them a 10, but you only needed to spend $5, then they're going to give you $5 back. What it means when you get change back, it means you gave more than what you were spending. You gave more money than what you were spending. Okay, so you have to understand what that part means. Okay, so do we know how much we spent yet? No. We know how much it cost. We know how many items we bought. We know how much money we got back, but we don't know the total amount that we spent yet. How can we figure out the total amount that we spent first? Jada? If I know the cost per item and I know how many items, what can I do to figure out my total cost? Ignore those numbers right now, Jada. A cookie. A cookie costs $2. You're going to buy 5 cookies. How much money are you going to spend? What did you do? What operation was that? Multiplication, yeah. So when we know how much something costs per item and we know how many items, we're just multiplying there. Keyword, per. Per was in the problem. Right, Bubba? Per was in the problem, not in the question. It was in the problem. So that means we're multiplying. We're going to take $2.60 per liter and we're going to multiply it by the number of liters. That's going to figure out our total cost first. So we're going to do $2.60 and we're going to multiply by 4.5. And that's going to come out to, on your calculator, you're going to see 11.7. Does that mean it's $11.07? No. What do we put at the end?
7.
No, not another 7. A 0. That's 70 cents. Please make sure you understand that in Delta Math, you guys, a lot of times you would type in like 11.7 and it would tell you you're wrong. Or IXL would tell you you're wrong because it's money. Money needs 2 numbers behind the decimal. Okay, so we know this is the amount of money that we have to spend, but we're getting change back. So in order to get change back, what we're going to do is we're going to take our total cost, not subtraction, we're going to add our change. Okay, if you take the cost and the change and add them together, that's going to equal the money we gave the cashier. Okay, we give them money, they take away our total cost and they give us change back. They're doing the opposite. But if we're trying to figure out, hey, I know how much money it costs, I know how much money I got back, I need to know how much did I give, you're going to do the opposite. You're going to add those together. So we're going to take $11.70 and we're going to add the $3.30. How much money did we give to the cashier? $15. And again, think logistically. If you're like, oh, well, I'm going to subtract in the problem, and you do $11.70 and you subtract $3.30, does it make sense that you only gave the cashier $80.40 if it cost $11.70? No. You have to give more money to them in order to pay off what you owe. All right, let's flip it to the last one. Let's go to our last page. All right, Henry's building a bench for his coffee shop. He begins with an 8-foot board. He then cuts off a piece that measures 3 and 5/8 inches, or feet, sorry. And then he cuts off another measure of 1 1/3 feet. So we want the remaining board. So there's 2 operations, but in this case, both operations are what? If we're subtraction, right? If we're cutting stuff off, we're cutting, that's subtraction, and we're going to cut again, that's another subtraction. So they are multi-step, but it's the same operation each time. So we're just going to be cutting off, which means we're subtracting. We're going to cut off 3 and 5/8 and 1 1/3. So we're taking the 8-foot board minus 3 and 5/8 minus 1 1/3. And that's going to come out to 3 and 1/24 feet. Okay, now this last problem has a lot that's going into it. Jacob wants to earn money for a car. He's going to do a lawn service. He first has to spend money to buy equipment. So if we spend money, what is that? That's subtraction, right? Right off the there, I know this is going to be a subtraction. I'm spending money. He's then going to start mowing lawns. He's going to mow 32 yards for $74.55 each yard. Each yard. What is that? Multiplication. So right here, we know we're going to multiply because of that word each. Then he plans to save 5/7 of his profit. He's going to save 5/7 of his profit. What operation is of? Times. Multiplication again. So 5/7 of the profit is going to get saved. So now, which one of these do you think we need to do first? Do we need to subtract first, multiply first, or do the 5/7 first? Okay, what am I subtracting from then? Do I know what I'm subtracting from? Nope. I don't know what I'm subtracting from. So I have to multiply first. I got to find out how much money am I earning on these yards. So I'm going to have 32 yards, and we're going to multiply it by $74.55. And that's going to equal how much money he earned. So he earned $2,385.60. Now I can subtract, right? I can then take the amount of money I earned and I can go ahead and pay off the equipment that I purchased. Christian? I can then pay off the purchase that I made. So I'm going to take my earnings of $2,385.60 and I'm going to subtract the money that I spent. So I'm subtracting that $435.82, and that's going to equal what we call a profit. Profit is found by taking what you earned and taking away what you spent. And what's left over is how much money you get to keep for yourself to use on whatever it is that you want to use. So he has a profit of $1,949.78. Now for that profit, what he's going to do is he's going to save 5/7 of it to go towards his car. 5/7 of that profit is going to go towards his car. So that's when we're going to take our profit, our $1,949.78, and we're going to multiply it by our fraction 5/7. And that's going to give us our car savings. So we save $1,392.70 for the car.